So let's try this problem right here. Why don't I distribute the negative to this, this, and that? Not to this because these pieces are attached. So that to these. And now maybe we can take the sign and distribute to those three pieces. And now we can use our properties of integrals, and we can take this 1, 2, 3 pieces and break them up into 3 different integrals. So each term got its own integral, integral dx, integral dx, integral dx. Now, why don't we take these coefficients like -1 and 5 and push them out to the front? And now what I'd like to do is I'd like to create a U-substitution for all of these. Here is what I'm saying. Why don't we let U equal cosine x and du would equal, well, if U is this, du is the derivative of U. What's the derivative of cosine? Negative sine x dx. And if you take this negative and kick it over, it'll be negative du equals positive sine x dx. So we can rewrite all of these parts, but instead of cosine, we're gonna use u. And instead of sine x dx, sine x dx gets replaced by negative du. Do that for all of these. So notice what I did. For instance, instead of cosine to the 8th, x cosine turned into u. That's why it's u to the 8th. How come it's negative? Because remember that sine x dx is negative du. So I put the du right there, but the negative, I put it sort of in the front. And I did that for all of these, where I put the negative in front next to the u for all of those. So now maybe I can take that negative, throw it out there, that negative, throw it out there, that negative, put it there. The double negative's knocked out, the negative became 5, that's negative. And so here's what we have, and now just take the antiderivative of all of these pieces. So the antiderivative of that is 1/9 u to the 9th, the 5 is there, that is 1/3 u cubed, negative 1/2 u squared plus c. And then by substitution, all of the u's become cosine. So let's see. The u's all became cosine to the power of 9. That's 5/3 cosine cubed x minus 1/2 cosine cubed x plus c. So the antiderivative of this, or the integral here, is equal to this right there.